Hi, this video we're going to talk about thermodynamics properties. For example, pressure, right? P, and the temperature. How about volume? Big V. And we also use specific volume. And we also use density to describe the property of the substance and something else. Like, for example, in chemistry, we use enthalpy, H, right? I'm going to write it down. Enthalpy. Then we also use, for example, U, that's considered as internal energy. We're going to use that a lot in thermo. We also use S, which is entropy, to describe the disorderness of the state. So there are those properties we use to describe a substance. And here we're saying those properties can be defined in two categories, extensive versus intensive. So what's the difference between them? Extensive which means it depends on size, depends on mass. However, intensive means it's not dependent on mass. For example, we have extensive. So what do you think about, for example, volume? Is volume depends on the mass? Yeah, it does, right? For example, if I have like big ocean water, that's huge volume, and then I just scoop out a cup of water, that's different volume. So it depends on the mass. It's huge body of mass versus only a mass that's in a cup. So that volume, it depends on the mass. How about pressure? What do you think about pressure? Pressure is gonna be intensive because regardless of the size, regardless of the mass. For example, you are in the classroom and the pressure over the left-hand corner is gonna be 1 ambience, right? In this big classroom. And then if you were trying to just somehow harvest a tiny little bit of air from the classroom in a container, right? And the pressure still is 1 atmosphere pressure. Even though the size is different, the mass is different between the zoom and between the room and also the container. However, they have the same pressure. So using the same logic, we know density is the same, right? Density does not depend on mass. I have a big chunk of gold versus tiny little gold nugget. Is the density the same? Yes, they are. So they are intensive property. And how about temperature? That is intensive as well. I have a pot of water that's boiling on the stove, and the temperature is 100 degrees Celsius. And if I were just taking out some bit of out, and the temperature is still 100 degrees Celsius, right? No matter the mass is big or small, I'm having the same temperature. So you start to see the difference of those. And here, there is a very fine line between them if you want to change from extensive to intensive. And here is an example for that. For example, we talk about volume. That is our extensive. But how about if I divide volume by mass? We learned about before, volume divided by mass is our small v. That's our specific volume. Yeah, in other words, for this extensive property of volume, however, which depends on the mass, but if we normalize by dividing it by mass, we are going to get a specific volume. Specific volume is going to be intensive property. Does not change with the mass because they're already divided by mass. Does that make sense? All right. So in that situation, we can use the same principle to come up with a few things here. For example, we talk about enthalpy, H. That is extensive property. But if we were trying to change that to intensive, we just divide it by mass. We're going to get small letter h. Okay? So that's going to be big H divided by mass. You start to see the pattern. If you divide by mass, you get specific, right? You get intensive. So we're going to call this small h specific enthalpy. Just like big volume divided by mass, we get specific volume, and we have this small v. All right, using the same logic, we can do a few more. For example, we're talking about U. That's called the internal energy. That's an extensive property, right? Because when you have bigger mass, you're going to have more internal energy, no doubt about it. Then, however, if you want to change that to specific internal energy, which is you divide big U by mass, you're going to get our small u. That is our specific internal energy. And that's going to be intensive. Then, one more, if we have this S, which is entropy, that depends on the mass. If we are going to get specific entropy, big S divided by mass, we therefore get our intensive property. And so you might wonder, why do we have to make that transition, right? Because when you define a system, then those intensive property is going to be the ones you can find out later on. For example, you given the pressure, given the temperature, then you can find this specific internal energy, for example, or specific enthalpy, for example, and then those tables are already pre-made or tabulated or through empirical data. So then once you know that specific intensive property, then you can go ahead and times your mass and get it extensive. Imagine if you don't have that intensive property listed, that data is going to be humongous because every single system have a different mass, right? So with that really simplify a lot of things. Only the last step, you just times mass to get your extensive property at the end. So hopefully this is helpful to explain about extensive and intensive. Main differences: intensive does not depend on the mass anymore. And if you divide by mass, that's how you normally change from extensive to intensive. All right, see you in that next one. Bye.